Alright, hello class. This is me going through exercise 5. This is exercise 5, string processing. Okay, so look, exercise. Wee exercises. Okay, um, what I'm going to do now is actually like let's start with string processing. All right, so quick run through. All right, so you know this is a string. This is a string. All right, b equals yay. All right, so a is a string, b is a string, a plus b is a string. All right, you can do stuff with strings. All right, you can convert to an uppercase. All right, note that when I do that, it doesn't actually change a. If I want to change a, I would say a equals to a dot upper. Okay, now a is that. All right, you can loop through strings. Loop. So for let me do that in the window. Okay, so to loop through a string, I'm going to say for I in range length of a string. All right, cow. All right, and then print I. Oh, sorry, I need to put the brackets. Print I, print. I guess I can't do anything about that. All right, this is what you get when I'm recording live. So s equals to cow for I in range. Oh, by the way, if you're okay with this, you can skip ahead at like a minute or so. All right, range len s. Okay, then I can print I, and I can print si. Okay, so this what it does is it should print 0, all right, followed by the letter 0 in s, followed by 1, the letter 1, 2, the letter 2, and then it stops. Okay, so I'm going to run this. Source must be saved, sure. Let's save as blah, my favorite. Alright, and I run 0C102W. Okay, another way of looping through. Okay, so keep in mind, right, this I can be anything. Alright, I can call it index if I want to be more precise about it. Alright, so what I'm going to do is I'm going to call for car in S. Alright, and I'll just print car. Okay, I'm going to comment these 3 lines out. Run it. Alright, I'll get COW. Alright, there's nothing special about the fact that I called this car, but I call it car because this is me looping through each individual character. Okay, so now I no longer have an index, but I do get each character each time I run through the loop. If I still want an index, I can have start index equals to 0. Alright, then when I get into the loop, I can say index plus equals to 1. Alright, so then I can say print index. Alright, so this will give me the same thing as before, 1C, 2W, and 3, 1C, 2, blah, 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 right? I would resize this window if I knew how to, but there's a W down here. You have to trust me on this, okay? Trust me. All right, so let's see. So the first one is ask you to ask the user for string input and then print it out in reverse. All right, so what string do you want to reverse? I love CEP, okay? So for a question like this, it's very straightforward. You just want to, you really just want to loop through the string, all right? Start from the back and print it out one by one. All right, not print it out one by one. Yeah, you can either print out one by one or generate a string one by one. So here's what I will do. So let me look for my exercise 5. Here. All right. So there you go. First we start by saying s equals to input what string you want to involve. Okay. Then this is the accumulator pattern. Right. That means we start with an empty string. All right. Then we use this I. Right. We can call it index as well. We use this index to loop through the string. All right. And then the character that we actually want, we want to start counting from the back. Okay, so let me, oh, I forgot to resize this. Excellent. Resizing is great. Look at me, I'm resizing. Whee! Okay, anyway, so yeah, what did I do? Right, A, oh, I do not have A. So let's say A equals to cow. All right, A bracket 0 is the first letter. A bracket -1 is the last letter. So in this case, if we want to reverse a string, we want to get something right from the back. So how do I get 0 minus index minus 1? All right. So for this one, we'll try and figure it out, right? So when it starts index equals to 0, all right, x equals to, but the first letter that you want is -1. All right. Index equals to 1. Second letter we want is at -2. All right. So and then when index equals to 3, index equals to 2, letter we want equals to -3. All right, so there's a pattern here, right? So 0 corresponds to -1, 1 corresponds to -2, 2 corresponds to negative 3. So we'll now say x, right? X is the letter we, rather the index we want, all right, is equals to 0 minus index. So in this case, 0 minus 0 minus 1. So again, minus 1. All right. Second time round, we have index we want equals to 0 minus index minus 1, and then minus 1 again, minus 2. All right. So now we have this index we want. Okay. So I'm just going to run this to show you that it works. What string do you want to reverse? Potatoes, potatoes, potatoes. Enter. Alright, and you get siota top, siota top, siota top. Alright, please say that out loud 3 times as fast. Oh man, it's very hot in here. Turn on the aircon. Alright, if I turn on the fan, you all will hear nothing but whirr in the background. Okay, alright. Second question, rod 13. Alright, so rod 13 means that you take the first letter, right? You shift it to the letter N, right? You shift it 13 forward. But if your letter is near the end of the alphabet, right, you shift it 13, you loop around the front, and it comes back. Okay, so we actually ask you to do it step by step. Start by doing this for lowercase messages only without punctuation. All right. So let's say, you know, I really love CP, so I will map to V, space will map to itself. Okay, so this is something you need to watch out for. R will map to E, etc., etc. Okay. So I'm going to show you the answers. Okay, so this is the full answer. All right. So I'm actually going to go through the entire thing. Second part says, you know, once you're done with that, you adapt your function to account for uppercase letters as well as non-letter characters. Right. That's when you want to use all these funny little string constants. Okay. Let me show you what these string constants are. All right. String constants, string constants, string constants. Okay. So string constants are in the string library. So the first thing you need to do is import string. Import string. Right. Then there are a bunch of constants that you can use. Right. String.ascii letters will give you A to Z and capital A to capital Z. String.ascii uppercase will give you capital uppercase. String.ascii lowercase. All right. Other things you might use are string.whitespace. All right. This is your usual space. This represents a tab. This represents a new line. This represents a new line. I have no idea what these are. All right, don't tell anyone. I don't know. All right. There's also string.punctuation, which are all the possible punctuation that you have. Okay. In fact, if you're doing your exercise 7, you'll be using these two, string.whitespace and string.punctuation. Okay. So my solution. I create a rod13 function. Okay. So this is the idea of a function. This rod13 function. All right. Some of you are still confused about this, but when it says write a function, right, it doesn't mean you have to print something. Okay, it doesn't mean you have to print something. Your function, all right, you have to read very carefully what the question asks you. Shh. The question might ask you to write a function that takes an input string and returns a string. All right, here we're not very clear on this, so you can do it either way around. All right, but in this case, what I have is a function that takes an input string and returns an output. So I start accumulator pattern again. Output is blank. All right, start with a blank string. All right, then I loop through every character in the input string. I start by checking, is it not in the ASCII letters? All right, is it not part of these? If it's not part of these, then, you know, who cares? I'm not going to rotate these, right? I'm not going to add 13 to it. So output will just add that output onto it. Okay, so you can imagine, right, the string that I get. Let's say I give you space, 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 space. All right, the first character that I get is space. It will go inside this if statement and say, oh, it's true. Then it will add on the space to the output. Then it will loop through and you check again, oh, space is true. Then you output space, 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 space. All right, completely useless cipher, completely useless message. Who tell you to be so stupid? Okay. However, if it is in ASCII letters, all right, now what? Now we check. If it's lowercase, all right, then we want to find the first letter to subtract from, the base. All right, that's what I told you before. Right, don't use, I know that odd bracket A is, odd A. All right, odd A is 97 and odd capital A is 65. All right, but I told you before, I would rather not you put 97 here. All right, because this is so much more clearer. I wrote this code like a month ago at least, right? So now, but still, I still know that, oh, you know, I'm looking for odd A. I'm not looking for 97, because if I wrote 97 here, I'll be like, oh, what am I doing? I'm very sad. I don't want to record anymore. Okay, But instead, look at me, I'm so enthusiastic. Okay, so anyway, so I find the base. All right, if it's a lowercase, the base is a lowercase a. If it's uppercase, the base is uppercase a. Then what I do is I find the odd of this current character minus away the base. All right, so let's say the current character is b. I'll take odd b minus odd a. All right, then I know it's 1. All right, then what I want to do is I add 13 to it. All right, if it's more than 26, I want it to loop back around. Okay, so let's say you know, I'm at letter number 25. All right, 25 plus 26. Right, sorry, 25 plus 13 is 38. 38 mod 13, it loops back around to 12. All right, so character number 25, y, loops back around to I assume this is L or something like that. Okay, I cannot count so fast. All right, then I set it back to a character. All right, so I set it back to a character. I take the base, I add it to the new odd. Okay, I set it back and I append it to the string. Then you know there's nothing else to write. Okay, because everything is settled. Right, everything is settled. I go back to the for loop. I loop through it again. It will handle every single letter. Handle. All right, and after that is done, return the output. Okay, so here you go. S equals to input. What string do you want to encrypt? Print the output. All right. Maybe clearer is maybe a way to make this clearer is new string equals to rod13s. All right, and then we'll print new string. What is this doing here? Delete. Okay, run. What string do you want to encrypt? I like broccoli. No, I don't. Alright, so there you go. Notice that I accidentally put in a 1 here, and it didn't do anything to it, because it's not the ASCII letter. Alright, so far so good, huh? Okay, question number 3. Question 3 is Morse code. Okay, so essentially you convert convert a piece of string to Morse code. We've given you a Morse list. Okay, some of you, you know, very clever, wait until I talk about dictionaries, then say, can I use a dictionary? Can I use a dictionary? Okay, yes, you can use a dictionary, but that means you type the stupid dictionary out yourself, lah. Okay, joke's on you. Ha. Alright, so anyway, I typed this out for you. You just need to copy and paste and, you know, account for any spacing issues. So let me open my exercise 3, 5-3 answers. There are 6. This is going to be a very long video. Okay, never mind. Anyway, so this is the Morse list. Alright, notice that, you know, it can actually put spaces. You can actually put new lines and stuff like that. Alright, so first thing I do is I convert it to lowercase. Alright, input, give me a string translate to Morse code. Alright, s equals to s dot lower. For each character, if it's equals to a space, I put in 3 spaces, right? Just because we have a lot of spaces running around. Otherwise, output equals to output plus. Alright, so if A corresponds to the first character, alright, then we want to take the odd A minus odd A lah, right? So if let's say the character I get is A, odd A, right? This is 97, right? But I want it to correspond to index number 0 in this list. So what I do is I take odd A minus odd A. Okay, then add a space after that. Simple. Next, alright, let me run this. Oops, sorry. I forgot to. What mistake did I make? You answer. Good, correct. Okay, so I never accounted for ASCII characters. So let's say I just throw in a bunch of letters. Alright, then it should work. Alright, even if it doesn't, you wouldn't know. Ha ha ha. Okay, number 4. Substitution cipher. Alright, so similarly, now instead of having a list that you substitute from, you just have a cipher that you substitute from. Alright, so what I'm going to do is I'm going to show you the answer. Answer showing. That is what I'm good at, showing answers. Alright, what do you want to do when you grow up? Show answers. Yay! Okay, sorry. So there you go. Import string. Alright, because I actually want to use ASCII uppercase. Alright, so give me a string to encrypt. Give me a 26-letter substitution cipher. Alright, convert it to uppercase. Alright, if it's not in uppercase, alright, then we just add it on. Again, this is similar to before, right? So for every character, first we check if it's in uppercase. If it's not, then we just tack it on. Don't care. Who cares about it? But if it is, alright, we get this index in the alphabet. So let's say if it's a letter C, this will be odd C minus odd A, which is 2. Then you will get the second letter in the cipher. Right? By second, I mean the index 2 or the third letter. Okay? I'm not going to run this because it's very similar. Oh man, my cat's crying. Alright, write a function that decrypts the message from the previous exercise. Okay, so this one, what happens is it's the reverse process. Alright, not too difficult lah. Aiya. So easy one. Still must go through for what? Okay, I'm kidding. Alright, so similar process. Alright, let me show you exercise 5 here and exercise, wait, this is 5. Am I doing 6? It's not doing 5. I'm very confused. I'm easily confused, guys. Alright, don't confuse me. Okay, so first 5 lines are all the same. Alright, except for, one is encrypted, one is not encrypted. Okay, then, alright, this one is the new one. This one says for character in S, if it's not in the cipher, right? In this case, I don't check whether it's uppercase or not. I check if it's not in the cipher, then there's nothing I can translate lah. Okay, then I just give you back your original. Alright, so if it is, I use this called cipher.find. Alright, find will use the index, right, and find the first occurrence. Okay, so let me show you. So let's say what is my A now? A is nothing. Potatoes. Alright, but if I do a.find p, it will tell me 0 because it's a bracket 0 is p. Okay, a.find, right, O, right, there are 2 O's, but it will give me the first one. Alright, say blah blah blah. Alright, so there we go. Then what you do is I do this thing where I do a car of I plus odd A. Right, I'll leave you to figure this out, figure what this is doing. Alright, but we are just reversing the index and getting stuff. Okay, this one shouldn't be here. Comment out, save, close. Okay, one last one. Alright, this is the tricky one. Ask the user for a long paragraph of text. Okay, write a function which counts the number of words in your text and the proportion that contain the letter E. Alright, so some of you are very clever. You know that your text contains 7 words, of which 3 this is only 6 words. 1, 2, 3, 4, 5, 6. Alright, I cannot count. I failed PSLE Maths. Okay, my aggregate score is 200 out of 300 because I failed PSLE Maths. There are 2 methods. Wait, if I fail, actually no, I don't need to fail to, don't need to get 0 to fail. How many do I need to get? But I failed my maths, so it's very hard to count. Wait, I think about this. Okay, I'm kidding. Ask the user for long paragraph, blah blah blah. Alright, so you can use a built-in string function, which you have learned this week. By the time you see this video, you should have learned about the split function. Alright, let me show it to you right now. Split. Okay, so let's say A equals to potatoes, curry. Alright, and if I want to, if I call split on it, alright, and I give it this delimiter, right? It's a delimiter, which means that it's the limit that you want to split at. So every time it encounters a comma, it will split it into a different part. Okay, so now when I do a.split, I end up with potatoes, and curry. I get a list. Notice once again, I have not changed A. If I wanted to do anything like that, I would want to do something like A list equals to a.split. Like that. Okay, then I have A list. Okay, of course I can do stupid things like a.split by O. Alright, in which case I would have gotten p tut sp tut s curry. Okay, notice it gets rid of the delimiter. Alright, so the way to do this, if you use split, alright, is you just split it, alright, using let's say spaces. Alright, then you can count the number of words. Alright, and then but let me show you the other method. Oh man, I'm gonna be late. Okay, this is. I need to close stuff. Do I still need this? No. No. Do I still need this? No. Do I still need this? No. Do I still need this? No. I needed that. Okay. All right. So this is the method where I actually construct a brand new string. Or rather I just count things as I go along. Okay, let me go through it step by step. I construct a new string by saying, first I check, I keep something around called is the previous letter that I checked a punctuation. You'll see why I need this for later. Okay, so the input string is called S. Right. So for every character in S, right, if it's in punctuation, right, remember these are string constants. If it's in punctuation, all right, I will set this thing to be true. Okay. However, if the previous letter was not in punctuation, all right, I'm going to append a space. All right, this is useful because I don't want to keep appending spaces for. Let's say I have 3 exclamation marks. Right, if I append a space every time I encounter a punctuation, I'm going to end up with a crapload of spaces lah. Right, so I only do it when the previous is not a punctuation. All right, so here at this letter, previous one was not a punctuation, it will append a space. when you get to here, previous one was a punctuation, it will not append a space. Okay, so that's just a tiny little optimization. Otherwise, new string equals to new string plus character, all right? And because it's not a punctuation, we set this to be false. All right, so this is a very common pattern. All right, you just have something that you just keep updating. All right, and then you use it to keep track of your previous item. So by the time I do this, all right, all right, let me comment out the rest of this code. Okay, and I will print new string. Okay, so give me a long text. Hello. Yeah. All right. So I've gotten. Looks like my algorithm didn't work very well. All right, but anyway, that's fine. I've gotten. I end up with. I've stripped all the punctuation. All right. So now what I want to do, I call this thing called rstrip. Rstrip gets rid of the white spaces on the right of the string. Okay. Then, oh man, this part is not my best code, I would say. All right, but I'm gonna start by counting the number of e's. Right, so this is where I made a mistake. Start counting from 0. Count from 0. Right, num e's. Okay, I have no idea. I have not read this. All right, 1 e already. So what I'm going to do is, all right, for every character in the new string, all right, I am going to say if the character is equals to a space. All right. Oh, sorry. Oh, this is to count the number of words. Okay, so this is why comments are useful, guys. Count number of words. All right. Count number of e's. I hope you guys can't hear my cat screaming at me. All right. So was there already an e in this word? Lol. Okay. So this lol is taking up too much space. Okay, so I'm going to, so what this does is I'm actually going to count both the number of words and the number of e's. Okay, all right. So for each character in the new string, all right, if the character is equals to a space, I'm going to add 1. All right. This might not work for, okay lah. This depends on you, stripping out all your spaces properly over here. All right. Better way to do it is probably to use split and use a space or something like that. All right. So yeah, so what this should do is, if it encounters a space, all right, that means we've gone to a new word. Otherwise, if it encounters an e, all right, you will add an e to it unless it's already been added. Okay. All right. So I'm not sure I'm not quite sure this thing works very well. All right, but hopefully this gives you a sense of what to do. Okay, that's it. Bye bye. That's all for exercise 5. See you next time.